Okay, so let's get started. I think we'll have a few more people joining just as we get going. So this seminar is going to be about usability testing in healthcare. And my name is Chris Paton. Let me just get the slides going. Yeah, so I'm the editor of a website called the Health Informatics Forum. I'm also a clinical researcher at the University of Oxford. And I've got a Twitter account and a LinkedIn account, which I'll show you at the end again. So if you want to get in contact, you can contact me through there. So just a little bit about how the system works. So this is, I think some of you have been on these seminars before, but basically you can use the audio to talk, or you can post questions in the chat box. And what I'll do is I'll go through the content of the seminar, and then we can have a discussion at the end. And what we've done before usually is just to post questions into the chat, which I then read out and try to answer. But you can use your microphone to speak up if you want to, and if you want to do that, you can put your hand up using the little hand signal. So just a little bit about the Health Informatics Forum before we start. So hopefully you've seen the website, but it's online social networking, discussion and learning portal for health informatics professionals around the world. And we've got about 11,000 members now. And there's a discussion forum where you can post questions about careers in health informatics or any questions you have. We also have online courses, and there's about 20 or so quite long online courses with a lot of video content. We also post news about health IT and digital health, and you can connect with other members and do social networking. So today's agenda is divided into 3 sections. So the first part will be talking a little bit about the science and theory of usability testing. And then we'll move on to how you do usability testing. So what are the different approaches and what are the different types of tools? And finally, we'll have a discussion with some questions posted in the chat. So let's get started. We're talking about the science of usability. So the way that a kind of very broad overview of digital health or health informatics interventions can be described is using frameworks from behaviour change theory. So behaviour change theory is quite often used in public health and healthcare for determining how you can get patients or clinicians to change their behaviours. So it might be something like stopping smoking or losing weight or adopting a new tool. And I think if you think of digital health apps and healthcare, electronic health record systems, things like that, as behaviour change interventions, because you want to get clinicians doing something new or patients using an app to help them with their healthcare. So in behaviour change, the Susan Michie framework says that there's 3 things that have to come together to change a behaviour. One is the capability. So that's the ability of people to do the behaviour change. One is the opportunity. So they need to have the opportunity to change their behaviour. So even if they're capable of doing something, if they're not given the opportunity to do it, then they won't be able to do it. And then finally is the motivation. So that is people wanting to actually change their behaviour. So for usability, what we're talking about here is the capability to do something. And you can increase people's capabilities for doing a new behaviour by training them or showing them how to do it. But you could also increase their capability by making the thing itself easier to use. And that's where usability can fit in. So one of the key areas to think about when you're thinking about human capability and digital systems is the working memory system. So working memory is your short-term memory. So it's how you make decisions and how you make calculations and process information in your brain in real time. And the working memory has got various different components to it, which we need to bear in mind when we're thinking about what are the underlying issues that might cause usability problems for healthcare workers. So at the overall top of working memory is your central executive. So this is the area of your brain that is involved in making decisions and deciding what to do next and what to think about and how to pull all the information together. And there's three modules that pull information into the central executive. One is the visuospatial sketchpad. And this is like an imaginary sketchpad in your head that you can use to create images that you can hold in your mind and rotate them and create thoughts. One is the episodic buffer. So episodic buffer means that we can bring into our mind an episodic memory, so a memory of an event into our short-term memory and use that for making decisions. And we also have our phonological loop. So the phonological loop is your kind of internal narration. So it's called a loop because you can, if you want to hold something in your memory, you can repeat it in your phonological loop to keep it in your working memory constantly. So there's probably, if you wanted to remember a phone number or something like that, you can keep the digits of the phone number in your working memory and do mathematical calculations and things like that using your phonological loop. And these three areas draw on deeper areas of the brain. So, for example, the language area is important for the phonological loop. Your episodic long-term memory, where you store your memories of previous episodes and all of the episodic memory that you have in your life interacts with your episodic buffer. And your visual semantic memory is important for bringing things into your visuospatial sketchpad. So visual semantics means factual knowledge of visual things. So the classic example is to ask people to think about their own house and count the windows. And you've got a semantic representation of your house, so like a 3D model of your house. It's not an episodic memory. It's not a memory of an experience of your house, but it's actually almost like a 3D model of your house. And in order to count the windows of your house, you'll rotate that model. You'll bring it into your visuospatial sketchpad and rotate the model of your house to count the windows. And then your central executive can then use that for making decisions. So this kind of component view of working memory can all come together to help us when we're making decisions and using information systems. So it's important to understand how that works and what are the different components. So once we have a kind of understanding of that, we could also need to think about the limits of our cognition and how this is going to affect us when we're using information systems. So these components that I'm describing allow us to navigate a complex world, but also have various shortcuts built into them and biases and problems. So one of the ways you can demonstrate this is through experiments where you try and test what the limits are of people's cognition. And one of these experiments was done with radiology CT scans. And this was done in 2013, and they showed a CT scan of a chest to radiologists and asked them to interpret the CT scan with regards to whether or not there was a potential lung cancer in the chest. And 83% of the radiologists, when they looked at this image and they looked for the nodes of the lung cancer, completely missed that there was a little image of a gorilla on the film. So if you zoom in, you can see that there's in the top right corner, which is in the left lung field, you can see that there's a picture of a gorilla that the radiologists all missed. And so the question that comes to mind is why such an obvious thing can be missed. And it's to do with how the brain processes information and what we do. And you might have seen similar things like this before. So perceptual illusions, they're called. So there's various ways that scientists have come up with to try and test how it is that we perceive information, and is it kind of a logical way that we perceive information, or how does the brain take shortcuts? So one of the perceptual illusions is this. It's called a color constancy illusion. So if you look at the squares A and B on this image, it looks like A is on a dark grey square and B is on a light grey square. But if we zoom in and then cover up the rest of the images apart from the squares, you can see that actually the squares are the same color. And the reason for that is the object is casting a shadow, and our brain understands what a shadow is and will actually alter the color that we're perceiving of things in order to make sure that we can see the world for what it really is. So in this is a made-up scene, but if this was a real scene, we would want to ignore the shadow. We want to know that shadow's there, but also to ignore it to some degree so that we can see that there's still a checkered board there. So this field of trying to understand how the human brain works, what our cognitive capacities are, what are the shortcuts and biases that our brain has evolved to process information in a complex world, is called human factors and ergonomics. And it's a branch of psychology, so it's applied psychology. So it's psychology applied to real world problems, and it's been going for 50 or 60 years and is well established in a lot of safety critical industries. So industries like airline industry, so how pilots navigate and fly aircraft, how aircraft traffic control works. Also things like oil rigs, oil exploration, so where they're working with very high pressures, and if there's a mistake that's made, it can cause injury or death. And also in healthcare, and traditionally in healthcare, it's been used in areas like surgery or management of emergency patients or anesthetics, where they try to make the systems more robust so that there's less possibility for error. And so this is the area that usability of health information systems fits into from a scientific point of view. So you can define human factors. It's also called ergonomics. And you might have heard of the term ergonomics applied to things like handles or chairs or objects you interact with. But so it's a similar type of thing to that, only but not necessarily physical ergonomics, but also cognitive ergonomics. It fits in with how the human brain works. So ergonomics or human factors is a scientific discipline concerned with understanding the interactions amongst humans and other elements of a system, and the profession that applies theory, principles, data, and methods to design in order to optimize human well-being and overall system performance. So the idea is that you're trying to use systems in a way that fits in with how the human brain and body have evolved. So one of the ways that this is applied in computing is around the area of human-computer interaction, which is, again, a field that's been established for a long time. They're not necessarily applied in healthcare. And in human-computer interaction, they've done experiments over a long time to determine various scientific theories and laws and proven them experimentally, which can be applied in the area of health usability and healthcare. So some of the examples of these laws are Fitts law. And Fitts law is a way of predicting how much time it takes to move things rapidly. And it wasn't designed initially with computers in mind. But if you were doing something like moving your mouse across the screen to click on something, Fitts law could give you a prediction of how long it would take you to do that kind, based on how the human brain works and how your hands work with a mouse. The Hick-Hyman law is about how long it takes you in your working memory to make decisions or choose different options. And so in computers, if you've got multiple things you can click on, you can use the Hick-Hyman law to predict, depending on the complexity of the choice, how long it's going to take you to make that choice. And the keystroke level model is really about these types of laws, but applied to computerization. So they've gone through various computer tasks, including typing on the keyboard, but also things like clicking on menus and things like that, to predict how long it would take with various different forms of user interaction. And then finally, there's lots more of these types of models, but the other kind of major one that's used is called GOMS, which stands for Goals, Operators, Methods, Selections, Rules. And these are combined things like that I talked about with the keystroke level model, but also include higher level processing, so including predicting how people will navigate around a computer system given various options and given various tools. So that's what I wanted to say about the science of usability testing. So I'll just move on now to, let me just check on the time. When we conduct usability tests. And so I did a previous seminar that I think a few of you came to, where I talked about how we design apps in healthcare. And there's a process called design thinking that is a nice overview of how modern applications are designed and goes through several stages. So there's empathizing with users, defining the problems that the users have and that you're going to solve, ideating solutions to those problems, prototyping, then testing, see whether your prototype solves the problems, and then implementing. And each of these stages, if you've got problems or issues, you can go back to the previous stage or even leap right back to the beginning again. So it might be that once you've created your prototype, you've decided that the prototype's just not going to work. And even before you've tested it, you decide to go back and make sure that you're addressing the correct problem. Or if you've tested your prototype, you might go and re-prototype and change it. And the same all the way through to implementation, where you can always keep going back to previous steps. And this process you can summarize as understanding the problem space, exploring ideas, and then materializing something so that you can do it. And usability testing and usability ideas are kind of embedded in this whole approach. So design thinking approaches will think about how the user experience is going to be for users from the very beginning, and the tests can involve, at an early stage, can involve doing usability testing. So some of the ideas that guide this process in a practical way. So design thinking is more of an overall framework rather than a detailed step-by-step strategy. Is lean UX, where UX stands for user experience. So that's about creating products that have got a good usability for the end users and work well in their environment. Scrum, which is about how we do agile development, how we manage this process of iterating and keep going backwards and forwards. And then lean startup, which is about how you embed this iterative design process in startup organizations. And that doesn't have to necessarily be a company, but it might also be a research project or a project that a large organization is trying to roll out, such as electronic health record. And that's about using data to gather end user experiences and feed that back into the design and iterative development process. So all of these ideas need metrics in order to work. And these can be, you can show this with the lean development cycle. So for example, if you're building an app, you might start off building something using app development, release it to some end users, and then measure it. And what you would measure could be your usability of your app. There might be other things that you want to measure as well, such as to test whether you're technically functioning correctly and whether you're gathering the right kind of data that's going to meet clinical needs. But you can also specify that you want to measure the usability in this development cycle. So in this way of thinking, usability might be something that you're constantly doing from the very beginning of the development cycle. It's not just something that's a stage that you've built in towards the end of development or even after the app has been developed and released. It's something that you do a lot, you constantly measure, and you try and track it over the long term. When we think about healthcare interventions and digital health apps as healthcare interventions, current guidance is to think of these as complex interventions, and there's been complex interventions in healthcare for a long time. So Something like a public health intervention, such as a campaign by the government to get people to exercise more, might be thought of as a complex intervention. It's not the same thing as a drug, which has one mechanism of action. It relies on a whole different complex suite of projects or ideas or initiatives. And these complex interventions, if we think of digital health or electronic health records or apps as behaviour change interventions, then they kind of fit into this way of thinking about complex interventions. And there's a framework that's been developed in the UK by the Medical Research Council for evaluating complex interventions. And part of this is to do a stage of feasibility and piloting where you would do usability testing. So it would fit in as part of this standardized research approach. And they would say you would do your development, then you would do some usability testing when you're doing your piloting, and then you would conduct a more formal evaluation and then implement and monitor over the long term. So you probably, if you're following this type of guidance rather than the iterative agile approach, you might have a set time in your protocol that you're going to do your usability testing. So some more other guidance for digital health, especially more globally, comes from the World Health Organization, and they have a monitoring and evaluation toolkit where they talk about where you should do your usability testing as part of your development and rollout of your apps. And for them, it's at the very first stage. So it's similar to the MRC complex interventions. So when you've got your prototype, that's when you do your usability testing with your end users. And then you go on to efficacy testing, effectiveness testing, and there's a kind of subtle difference between efficacy and effectiveness. Effectiveness generally refers to more real-world testing. And then you do your implementation science, which is monitoring your implementation as it scales out. So for them, usability comes at the very beginning and might even only have a very small number of users, so 10 to 100, they say. So these kind of frameworks are quite useful to bear in mind when I talk about the different ways you can approach usability testing from the usability industry. And you can kind of see if you're applying usability testing in a healthcare context where people have kind of said it should be applied. And there's a bit of a difference between how you would do, say, a lean or agile approach to how you do a more traditional research approach or monitoring and evaluation approach to usability. So what kind of usability testing methods are available? So I've grouped these into two main categories, and this comes from the usability testing industry. The first category is expert evaluation. And expert evaluation is where a usability expert or a human factors and ergonomics expert will look at the app or the product and do an evaluation of it on their own, essentially. And these fall into two categories of heuristic evaluations and inspections, they're called. Then secondly, we've got more formal usability testing, and this can be done in a lab. It can also be done remotely. It can also be done with mobile devices, and also can be done using tracking through a server connected to the internet. So you can use analytics for tracking. So we're going to talk about those things in a second. So first of all, let's talk about the usability heuristics. And these were invented by a psychologist called Jakob Nielsen, who's quite a famous usability expert. And he's got a website called the Norman Nielsen Group. So he's partnered with a person called Don Norman, who was one of the early Apple user interface designers. And over the last 20 years or so, they've come up with these heuristics, or heuristics means rules of thumb. So they're kind of guidance that's not necessarily scientific, but just things that have worked over the years and that they as experts think are important when designing systems. And they've boiled them down to these 10 criteria. And if you go to the NN Group website, you can see these, and they've written articles about each of these to go into more detail, so you can have a look at that if you want to. So the first heuristic or rule of thumb for developing usable systems is visibility of system status. So this means that the system should always keep the user informed about what's going on with appropriate feedback within a reasonable time. So this might be something like if you're downloading a file off the internet, you should see a progress bar to show you how much has been downloaded, so you're aware of what the computer's actually doing. If the screen just went blank for 10 minutes, you wouldn't know what was going on. So you should have some kind of indicator about what the computer is doing. Or if it's not a computer, if it's something else, you should have be able to see what the device is doing. And then secondly, there should be a match between the system and the real world. So what this means is that you shouldn't make up new symbols or language for an information system that the users are not likely to be familiar with. So you shouldn't use very technical computer terms when you're dealing with a system that's going to be used by doctors and nurses, for example. So you want to use everyday language or icons and descriptions that they will be able to easily interpret and follow real-world naming conventions, and also present them in a natural and logical order. The next one is about user control and freedom. So this is where if you get partway through a task in a system, you need to not have to finish the task if you don't want to, or you shouldn't get stuck down a bottleneck of a system and not know how to get out. So this is something you might see when you're registering or logging onto a system, and it's asking you to keep putting in information. And if it's like a checkout on an Amazon store or something like that, you might decide you want to cancel and think about it a bit more before you carry on. And if you're a doctor, it might be that you're ordering a test for a patient or something like that. The system shouldn't get stuck halfway through and require you to continue through to the end. And you should be able to easily exit the process. And also with this, they say you should also be able to undo and redo. So you should be able to go backwards and forwards through a process. You shouldn't, if you go back, you shouldn't lose what you've added on the next screen. So the next one is consistency of standards, and this means that if you're using a term, you should use it consistently throughout the program. So if you want to search for something, it shouldn't be search on some pages, look up on another page, or find on another page. You should use the same thing for the same function throughout an app. And icons or buttons should do the same thing, and you should try and keep it consistent. So your save button should always look like a save button and shouldn't have different icons or different ways of doing things. Another thing to bear in mind with that is it's not just for the individual app that you're developing, it should also be with other apps. So Jakob, Nielsen and his colleagues do a lot of reviews of things like corporate intranets and particular types of websites, so like banking websites or something. And what users expect is consistency in standards across the whole type of apps that they're using. So if you're using a mobile phone app, you expect the user interface to behave the same, even on different apps, and the same buttons to mean the same things for different on different apps. Then the next one is error prevention. So ideally, you prevent errors from happening in the first place. So you make your system easy to use so people can't make errors. But if people do make errors, you should design your error messages in a straightforward way that means something to users. So you don't say system critical memory dump error 54321, which doesn't mean anything to the user. It should tell them what the error is and why it's been caused. But ideally, it should prevent them from making errors. And one of the ways of preventing is to think about these cognitive biases or cognitive challenges that we as human beings have, and ensuring that we confirm things before they commit. So for example, in that CT scan we could say, could you confirm that you've checked all aspects of the lung field before you submit your diagnosis of lung cancer, in order to get them to make sure that they've checked not just the area that they've been told to look at, but all areas of the lung field to look for unexpected things. The next one is recognition rather than recall. So this is about minimizing the memory load. So if you remember when we're talking about the phonological loop in your memory, you can only hold a limited number of items in that. So it might be, if you're on a page of an EHR system and it says to order a test, and then on the next page it asks you to enter in the patient's number without showing it to you again. So that might require you to constantly keep the patient's ID number in your phonological loop as you go to the next page, and then you've maxed out your cognitive capacity, and that can lead to errors or poor information. So they shouldn't have to recall information as they go from one bit of a system to the next. You could get them to double check things by presenting them again with the information. Say, oh, are you sure this is a test for Mrs. So-and-so, which is the one that you were looking at before? So they can recognize what they're ordering, but you shouldn't be asking them to hold things in their memory, because there's a limited amount of capacity to do that. The next one is about flexibility and efficiency of use. So this is about how some users of systems can become experienced as they use them and not require the same level of simplicity that novices might have. So if you imagine using a digital radiology system, an experienced radiologist who's been using the system for a long time might want quite advanced features for doing things like highlighting particular areas or using artificial intelligence algorithms in a complex way. And these should be hidden from the novice user so they don't overload them, but should also be accessible for the expert user so that the system is flexible and minimizes the time it takes to do things for expert users, whilst still being easy to use for novice users. The next one is aesthetics and minimal design. So this is about the tendency for some designers to put too much information in. And again, this is thinking about how our brains work and how we process information. But you should minimize the amount of information necessary to make decisions or complete tasks on a system. So what quite often happens in electronic health record systems is that they just put all of the information that they've got in the database on a screen at a time. So even if you're just interested in one patient, you might see a list of 20 patients, and each can do tasks related to all of them. So what you might want is a more simple, minimal, and aesthetically pleasing screen where it's very clear what your tasks are in order to reduce errors and reduce the chances of confusion and information overload. So this 9 relates to one of the previous points where we're talking about the error messages should be expressed in plain language and indicate what the problem is so that you can go about solving it. So it shouldn't just tell you what the error message is, but it should also say this error can be caused by the fact that you haven't entered in a bit of information on the sheet, or that the system hasn't gathered the right amount of information. And then finally, the last heuristic is about help and documentation. So ideally, systems work best if you don't need documentation to use them. So most apps that we use day to day on our phones and things like that don't require documentation like software used to have a software manual that you'd have to read before running a program. But if you do have documentation help, you have to make sure it's easy to use and easy to search. And there's various guidance on how you can list steps for getting people to show people how to use systems. So if you take those 10 heuristics, you can get quite a long way in designing systems that have got a high chance of being usable. And this is especially useful if you're, say you're working on a project on your own, or you don't have a budget for conducting tests with end users. Or you just want to do a first draft of a project before you show it to end users. If you think about these things as you're designing and developing it, then it can get you quite a long way to making sure that you're not making common usability mistakes. So what I want to talk about now is going beyond. I just mentioned at the end of that about other inspection methods. So when we talk about expert inspection, it quite often refers to things like bringing in an expert to go through these steps and check. But experts also have experience of different systems in a less tangible way. So they can come in and do one of these heuristic evaluations, but they can also do a walkthrough where they will go through a system and make notes at each step about what the challenges are and what the problems are. And you can do other expert inspection methods. But what I'll talk about now is how we can conduct more formal usability testing. So this is about using and getting end users to come and test systems. And this has been done, again, this has been done for a long time. And there's international standards for how you can do usability testing in this way. They refer to it as the ergonomics of human system interaction. So this isn't specific to healthcare, but is about doing a human factors ergonomics assessment of a computer system or any other type of electronic system for checking on whether or not it's usable. And if you apply these kind of a standardized approach, then you can compare across systems and use the same kind of metrics and terminology when you're making comparisons. So the three usability measures that are contained in the ISO standards and are commonly used across usability testing are efficiency, which is how long it takes to complete a task, effectiveness, which is how many tasks are completed without errors, and satisfaction, which is how do users feel when they're using your app or using your system. So Abigail's just asked, are we going to get this recording? Yes, this will be recorded. And I think there was another item that said that they wanted to receive a previous recording. And what I'll do is I'll post up all the previous recordings as well on the website. So let me just carry on. So measuring efficiency. Efficiency is about time to task completion. So you would measure this by setting a user a task and then timing how long it takes them to complete the task. So a study I was looking at recently was around ordering tests through an electronic health record system. So they would ask the user to order a test, and then they would time how long it takes them to successfully order the test. So this could be an e-prescribing system like I described. It could also be a PACS system. And if you're comparing this is a photo of someone searching for radiology films. So if you're comparing a PACS system efficiency to a paper-based system efficiency, you should really include going down to the radiology department and finding the films versus searching for it on the PACS system. So it can be used to demonstrate not just whether or not your IT system is working correctly, but how much more efficient using the IT system is than using other methods like paper or physical methods. And then measuring effectiveness is about percentages of tasks completed. So this is about if you ask them to order a test, whether or not they get through to the end of the process. So with some systems, if you've got poor usability, they might only get halfway through ordering a test, and 50% of the time they don't manage to order the test properly. They have to do a paper prescription or get someone to help them or something like that. So your measure of effectiveness is your percentage of tasks completed successfully, and you can also use this to log errors. So different types of errors will prevent people from completing tasks. And also this is also about accuracy. So with a medical system, if your task is to accurately diagnose something, if you make a misdiagnosis, then you could say that that was an error of effectiveness of the system. And then finally, satisfaction. So satisfaction is commonly measured using the system usability scale. And the system usability scale was developed by John Brock from Digital Equipment Corp in the UK in 1986. So it's been used for a long time now, and it's quite a simple scale. There's been a few adaptations to it, and there's been a clinical usability scale developed and various others. But generally, you can use the system usability scale and just customize it yourself to your system. So this is an example of what it looks like when thinking about a website. So there's 10 questions, such as, I think I would use this website frequently. I found the website unnecessarily complex. And you can change the word website to, PAC system or EHR or whatever the type of system is. And then they score whether they strongly disagree to strongly agree. And then depending on the answers to this, there's a scoring system that either adds scores or takes them away, depending on whether it's a positive or negative question, and gives an overall scale of user satisfaction. So you can see that these measures, efficiency, effectiveness, and satisfaction, can give you an overall metrics of how usable the system is. But you also have to bear in mind that you're not aiming necessarily for maximum scores in all these areas. Because if the system is very effective and efficient, it might not necessarily be satisfying to use. For example, if you're a doctor working on an electronic health record system, you might want free text to record your notes about your patient, because it's much quicker for you to do it, so it's much more efficient. And you find it a lot easier, so it's more satisfying. But it might not necessarily be the most effective way, because you might be introducing errors. So it might be better if you used a structured form where you choose from a selection for your inputting. But then if you did that, then you might be slower doing it, so you might have reduced efficiency. And also you might get frustrated, so you might have reduced satisfaction. So it's quite important to balance all these things and think about it, think about these measures individually and not just in the aggregate. So just to talk a little bit about how you go about the kind of physical conducting. So the traditional approach is the Usability Lab. So you might have 2 rooms. In one room, you have a couple of people, normally the participant and a moderator, and you might have a technical assistant or another moderator. You have your equipment that you're testing, and then you have various bits of recording equipment. So you might be recording the screen, might be recording audio, you might be doing video recording, eye tracking as well. And you might have a timing system to ensure that you know when people are doing various tasks and how quickly it takes them to complete the tasks. So Felix has just asked a question, when measuring effectiveness and efficiency, how do you take note whether a task was completed successfully? Is it monitoring a database at the back end? So in the Usability Lab, it will be the researcher that records whether or not the task was successfully completed. And I'll talk a little bit more about remote testing and unmoderated testing as well in a second, which goes over that. So one room in your lab might be the testing room, and the other might be an observation room. So these traditionally were set up with like a one-way mirror. So you have one moderator in the room with the participant, and then you might have other people, other researchers observing through a one-way mirror or through a TV screen, so that they're not interfering too much with the person completing the task, depending on how much information you want to try and get out of the experiment. So moderated usability test, so this is where the person is there, not necessarily with their hand on their shoulder like in this diagram, but might be sitting just behind the user. There's different ways of getting people to say what the challenges are. So first one is the concurrent think aloud method. So concurrent think aloud, or CTA, that means that the user's asked to talk through what the challenges are as they're doing them. So they say things like, oh, I can't find the button I need to click on, or this screen doesn't make any sense, or it's too complicated. So this has got an advantage of it's quite quick to do, because you get all the information as they're doing it. It's quite accurate because they don't have to remember what they're doing, but it can interfere with the process. So if you're timing how long it takes them to do task and also asking them to talk through it, they might take longer because they're talking through the problems. Retrospective think aloud, or RTA, tries to accommodate these issues, where they complete all the tasks and then they tell you what the problems are afterwards. The problems with this are they might forget, and also that it extends the amount of time that you've got testing. So if you've got 20 people going through testing a system, it might take them twice as long if you do retrospective think aloud. Concurrent probing is where it's, the moderator is actually asking the person as they're doing the tasks how difficult they're finding it or what the challenges are. And retrospective probing is similar to the retrospective think aloud, but it's the moderator asks them specifically, and we might have a structured questionnaire where they ask them specific questions about what they found problematic. So that's how a lab setup works, and that's the kind of traditional way of doing usability testing. But nowadays there's lots of new tools, and we can do remote usability testing. And this is cheaper and more convenient for testers, so they don't have to come into the lab or get transport to the lab. It does require that they're on the internet and that the software set up, but this isn't really a problem nowadays. Getting the software set up might be a problem, but the internet connection probably isn't. They do normally need to install screen recording software, so it might be software like we're using at the moment, where you download it onto your computer and it can record the screen. This lecture is I'm recording it as I speak, and you can use this similar type of software for doing your usability testing, where you just record someone as they're clicking through and using the software. You can moderate this or not moderate it. So you can, even if they're remote, you can still be on the telephone to them or on a video conference with them, asking them questions and doing the same kind of probing, or getting them to talk aloud what they're doing. The other thing you can do with remote usability testing is use analytics software. So you can try and, if you get them to log on to a system, you can then remotely gather data from the server on what buttons they clicked on and how they interacted with the software. And that's quite a common way of doing testing, usability testing nowadays. So eye tracking, this is where you use a video of the eyes of the participants to work out where they're looking on the screen. You can use this to create heat maps. So these are areas they've looked at a lot, or lots of users have looked at a lot, or you can do these saccade pathways. So saccade is the kind of jittery way the eyes move. They don't move smoothly, they dart from place to place, and it kind of maps out the track that they're taking around the screen. You can also measure pupil size, which is obviously related to their emotions as they're reading their information or doing it, and can be a measure of cognitive load. This requires you to use specialist software, and sometimes you might need to do it in a lab-based situation to make sure it's done accurately. With mobile devices, it's pretty similar to how you would do usability testing with laptops or desktop computers, but you might need to either use a video of the device because you want to see, not just because you don't have a mouse, you might want to see where their finger is hovering over and what they're doing with their fingers and hands, as well as the actual screen. And again, this can be moderated or unmoderated or lab-based or remote. But if it's remote, obviously it's more difficult to get a video set up of them using their hands. So just some quickly before we finish and take some questions, there's a few tools that are commonly used. So the most common one probably is Google Analytics. And this means for both mobile apps and for websites, you can gather data on how people have clicked around your app, how much time they spend on the different tasks that they're doing. And if you set this up correctly, you can get some quite good usability measures out of it. Screen recording software, so there's free software that you can use like QuickTime on Macs or Cam Studio, and this can be set up so that you record a usability session. It's also commercial software, so the software that we're using at the moment, GoTo Training, is also called GoTo Meeting, which you pay a subscription to be able to use, and Camtasia is another screen recording system that's commonly used in e-learning. But there's quite a few others. There's probably 10 or 20 different types of screen recording software, including screen recording specifically for usability testing. There's some quite nice new remote testing tools designed for usability testing. So Usability and Full Story. I have tried using Full Story, and it's quite an interesting way of doing usability testing. It basically, you put JavaScript on your website and it then tracks the cursor more directly and the text that people are typing into a website. So Google Analytics probably just says what pages people are using and how much time they're spending on them. As Full Story will show exactly where they're moving their mouse and also what they're typing into the search box and things like that. And Usability is another system like that. I haven't actually used personally myself, but is designed around producing statistics for remote usability testing. So that's all I wanted to say, really. It's been a bit of a quick overview of usability testing and all the different methods, but also I think important to remember that there's a science behind it, and it's about how, if you think about it from a human factors ergonomics point of view, it's about how our brains work and how humans can cope with the type of information that's presented to them on computer screens.